The introduction of this assignment is waste recycling is an important way of saving energy and material in production process. In general cases, recyclable objects are mixed with unrecyclable objects, which raises a need for identification and classifications. This paper proposes a convolutional neural network CNN model to complete both tasks. In addition, CNN consists of various types of layers: the convolutional layer, the pooling layer, and the fully connected layer. Convolutional layer and pooling layer are the layers that cause ANN and CNN to be different. In the absence of two layers, both layers have a role in the stage of looking at the image to find features, but the function and working of the fully connected layer on CNN are NNN calculations, so that they have the task of determining the result of feature with enumerable label. So this is study we are required to do two tasks, which is task 1 need to be design our own CNN model to train the data without overfitting or underfitting, and the task 2 required to repeat the training process, and we will use the pre-trained model from VGG16 and VGG19.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Nurul binti Adam and my matrix number is AE180055. So today I will present on about the methodology of our project, which is we need to construct and simulate CNN model based on specific number using Google Collaborator software, and there are consist several parts, as you can see at the mind maps or the flowchart. So before part, we need to do understand the task of assignment, and then after that we do the research on the Google Collaborator, and then after that during process we will do the start to construct the CNN model based on the task of assignment, and then we do the debug coding, which is this is the error checking phase, and then we reconstruct the CNN model based on the assignment, and we do the CNN and then after that we did the CNN model successfully, designed with all the factors that have been mentioned, and last is we publish and compile the report.
Assalamualaikum and Hi, my name is Noeliana binti Muhammad Ilyas, matric number CE180089. So in my part, I'm going to show a demonstration of results in task 1, model 1, which is I'm going to use a Google Colab. So here is my Google Colab, which is I'm doing for task 1, model 1 by using CNN. This is the question that asked for. So in this Google Colab, I have write for the step 1 until step 7 to form the graph. Firstly, I'm going to connect with my Google Drive that I have contained a file and train, and the pictures of can and also the pad. So now I'm going to click here, run cell. So here I have to firstly connect with my Google Drive. I'm using my email address, and then click allow to run, wait until the output will come up. Okay, here is the mounted add content G drive, which have been detected in my G drive. So next is step 2, which is feed dataset directory. So I'm going to run the cell. The content of my G drive for the pet picture and also for the can picture, which is in the recycle in my drive, and then it has input OS, and also the output shows the content G drive in my recycle folder. The step 3, I have to create, train and validation data directory. So click on run cell. As you can see here, it shows the output, which is can train length, which is 156, the pet train length, which is 310, and also for the can file length, which is 77, pet file length is 133. This is just to run the cell, which is by import TensorFlow, which is by Keras, and also for the step 4, we're going to construct the CNN model by run the cell. As you can see here, the output is displayed model, which is sequential, and the total parameter here, as you can see, is 19034.177. The trainable parameters is 19034.177, which is similar to total parameter. So non-trainable parameter is 0. Next is for step 4, which is pre-process the input data. The run cell is done and the output will come up. As you can see here, it found 466 images belonging to two classes and found 210 images belonging to two classes. Data batch shape 20, 150 and 150 and 3. The label batch shape, which is 20. For the step 6, which is I'm going to start training process. Epoch is starting to process, which is until 10, 1/10, which is we have to wait. Now the epoch is complete 1/10, which is 24/24. You have to see in accuracy, which is we have here the highest number of accuracy at line 8 and 9, and which is the accuracy is 1. And to compare these two, we have to look by the val_ACC, which is the line of 9, which is the highest than the line of 8, which is 0.9095. Next is step 7, the last step, which is to plot the outcome, and this will display the graph. So it shows complete answer. Enter is displayed the graph of training and validation accuracy and also training and validation loss. This accuracy is 1. The minimum accuracy is 0.65 for the training and validation accuracy. For the training and validation loss, in line as you can see here, 0 until 2, it has the highest accuracy, which is the line for 02 until 06.
So we are back with the simulation. This is the simulation for the task 1 model 1.1, and in the model 1.1 we need to find a PET bottle 1.5 liter or 0.5 liter and an aluminium can capture 3 pictures, and we need the condition is first side by side, second is PET bottle backward, and third is can will be at the back of PET, and then we need to fit all the 3 pictures to the model. So first we need to connect with our Google Drive as here, and this one is I already run and it already mount at my G Drive, and then this is for fit data set as usual, and then we need to create train and validation data, and as you can see here, this is my result, which is can train length is 156, PET train length is 310, cat val length 77, PET val length is 133, and new can PET length is 3, which is new can PET length is my new picture, which is that I capture for 3 picture that I mentioned before this, and this is the crash application. And then we need to construct the CNN model, and after we construct the CNN model, we can know the total params, trainable params and non-trainable params, which is non-trainable params is 0, and total params and trainable param is 19034,177. And next is we need to do the pre-process the input data. So at here we can find the 466 image belonging to 2 classes and 210 image belonging to 2 classes, and that data batch shape is 20, 150, 1503, and the label shape is 20. Next we need to start training process, and this part is take a time because this we need to do the epoch, which is 10, and this is the size, which is 24. So after at here we can know the accuracy, which is this accuracy is 1, but the val accuracy is 0.9095 and 0.9289, sorry 0.9286, but we will choose the val ACC 0.9286 because this is because the val ACC is more higher than 0.9095, and then we do the plot the graph, and as you can see at here the plot of the graph, we could find this is the graph. It it was gradually up and then down and up and down. So this is the training and validation accuracy, and this is training and validation loss. Next is, this is the part that we need to fit sample image to observe which pet and or can is dominant. So at here we need to do the image, we need to do the software image keras pre-processing image load, and then we do the image array and prediction and score, and this we need to print image. So as here, as we know, the answer is, the result is the image is 100% can and 100% pet, and this is the when we need to display the image. So at here we can see the image is can and pet is side by side. Same go with the new cam pet backward at here, and then we do the third image, which is the cam backward.
So I will continue for result in task 2. Task 2 in Google Colab. So for train the VGG16, for the step 1, import the library. Okay, done. Then for step 2, connect to Google Drive. Okay, for step 3, we need to feed the dataset directory. Okay, then for step 4, we create the train and evaluation data directory, which is contain can train length, pet train length, and validation length. So step 5, construct the CNN model. Okay, this is the result for CNN model. So step 6, construct the picture model with GGG16. Next, for pre-process the input data. Okay, we found 460 image belong to 2 classes, and found 210 image belonging to 2 classes. So for step 8, start training the process, which is epoch 1 until 10. So for step 9, plot the outcomes, which is need to generate the validation and training accuracy, and training and validation loss. So for VGG19, we use the same step in step 1 until step 5, but in step 6 we use VGG19. Okay, for pre-process, the input also the same in the previous VGG16. Okay, for step 8, start the training, we still use epoch 1 until 10. And last step is step 9, which is to generate training validation accuracy graph and training and evaluation loss. So we go back to graph training and validation accuracy and training and validation loss for VGG16. So here we can see the maximum accuracy for training and validation accuracy is 1 and minimum 0.65, and for training and validation loss the maximum is 2.5 and minimum is 0. So this is the dot one is referred to training loss, and the line 1 referred to validation loss. Also same for the training evaluation accuracy. For dot 1 refer to training accuracy, and the line 1 refer to validation accuracy. for the graph in VG19 also same, the maximum accuracy is 1 and minimum is 0.65, and the maximum for training and validation loss is 2.5 and minimum is 0.
From our assignment 2, we have to conclude that from 2 tasks given in this assignment, we can analyze various vision system strategies that can be suitable for each problem statement. Each task problem statement represents a study of convolutional neural network, which is CNN, objects detected applied to the identification of recyclable materials. During the developing software with a free GPU from Google Collaborator in this assignment, observation will be made, where the demonstration also showed a solution in Task 1 and Task 2. As a recommendation for this assignment, Task 1 and Task 2 need to be improved the performance of this recyclable material classification system by using the CNN. This recommendation can be used for the next assignment, which is can use the clear image in the dataset in order to get the best performance and use many types of the waste material in dataset. And lastly, can improve the collab program, which is in order to get the better results. So that's all from our group. Thank you.